Um, at this point, we want to do a comparison between these two products. One is called a dot product that you've learned actually in your earlier year. Dot product has another name, it's called a scalar product. And then there's this thing also that's called a cross product that you just learned. Right. To help you understand them better, it is good to make a simple comparison. To start off with, right? The definition. A dot B by definition is the magnitude of A, the magnitude of B, cos of the angle between them by definition. Whereas in the case of cross product, A cross B is magnitude A, magnitude B, sine theta, and then n cap. Based on the definition, you want to realize that A dot B produces a number. This is a numeral. Okay, a numeral is sometimes described as a scalar. Right, scalar. Okay, so this is actually a scalar, a number, right? A number. It produces a number. However, in the case of cross product, this end result is actually a vector. So this is a big difference, right? So let's also recall that in the case of cross product, the right hand rule actually applies. So that if you have to perform A cross B, moving your finger from A to B, the direction of the thumb, in this case, which is out of the board, right? Let me show you again. The direction of the thumb points to you, the vector of A cross B. In this case, is out of the board like this. So the first big difference is one of them produces a number, and the other one produces a vector. Okay, where are we right now? In my notes, we are on this page, okay? On this page, with this comparison. Alright, on my note is page 111. We are on my notes. I think it should be the same for yours as well. Page 111, the comparison table, right? So in this comparison table, first the definition. I'm highlighting to you that this is actually a number, whereas this is actually a vector. This one uses cosine, and this one uses sine. And then the alternative way to perform dot product, if you have a vector A and B in column vector form, right? If you have two vectors A and B, to perform the dot product, you have already learned that the alternative way is for you to take A1 times B1 plus A2 times B2 plus A3 times B3. Right? This is the alternative way to find dot product if they are in column vector form. On the other hand, in the case of cross product, you have already done it a couple of times. How do we perform cross product again? To perform cross product, you cover the first row. You find so-called the determinant. Actually, it's a determinant. If you learn matrix, right? Matrix, 2 by 2 matrix, right? You cover the first row. You have a 2 by 2 matrix. You find so-called the determinant. So in this case will be A2, B3 minus A3, B2. Right, this is the first one. Oops. Let me write properly. So this can be a vector A2, B3 minus A3, B2. Alright, and then you again cover the second row. You have A1, B3 minus A3, B1. Just that for the middle row, you want to put in an extra minus. And then when you cover the third row, you have A1, B2 minus A2, B1. Right. So this shows you another difference between them. And thirdly, if you have parallel vectors, okay, if two vectors are parallel, then A dot B, right? If they are parallel, then this angle is either 0 or 180 degrees. It's either 0 or pi. So this number, if it's 0, this number will be 1. If this angle is pi, this number is minus. So if you have two parallel vectors, the end result is plus or minus this, depending on the angle. Between angle theta, is it 180 degrees or is it 0? If these two vectors are parallel and in the same direction, then theta will be 0. Right? If these two vectors are parallel, but in opposite direction, then the angle theta will be 180 degrees. In particular, there's a very important result that you want to note of, If the two vectors are the same, if you have the dot product, the vector itself, this will give you the magnitude of A squared. Right? Because if these two are the same vector, then they are in the same direction, the angle between them is therefore 0. Then you got magnitude A, magnitude B, cos 0. Cos 0 is 1, so that's magnitude A squared. It's a very it's a result that is sometimes used in calculation. On the other hand, if you have parallel vectors here, parallel vectors, okay, say A parallel to B, right? If A is parallel to B, then you want to know that the cross product between them will be a 0 vector. Because if they are parallel, then this angle is either 0 or pi. Whether this is 0 or pi, this angle is 0, so this entire vector will be a 0 vector. Okay, then there's also perpendicular vector. If A and B are perpendicular, A perpendicular to B. If A is perpendicular to B, then this dot product is actually 0. If they are perpendicular, if A is perpendicular to B, right? If A is perpendicular to B, we have actually a result that we did in the notes. A is perpendicular to B, then the modulus of the magnitude of the cross product is just magnitude of A and then magnitude of B. Okay. And then the other properties, you can actually read it in this page of notes. Right? This note provides you with the rest. Just read the last two, the other properties and the applications. Right? So this page gives you a snapshot of the differences between the dot and the cross product. So this page will help you to consolidate a bit of the link of these two, the scalar product and the cross product. Right? There is actually another aspect about scalar and cross product, and this is covered in the next video where I show you a video on projection.